Knock knock. Who's there? Acorn. Acorn who? A corny squirrel who thinks chipmunks are just budget squirrels. Okay, back on track, Alvin. Okay, cue the footage. Howdy, I'm Alvin. No, you're not. But okay, I'm Shriya, and this is Georgia. We took it upon ourselves to do a project focused on observing and understanding squirrel behavior around campus at the wonderful Georgia Tech. Why squirrels, you ask? Well, squirrels are great organisms to study ecologically and behaviorally due to their daytime activity, easy observation, and ability to be tracked. It was hypothesized that squirrels preferred sunny weather. What was with this? And yes, that would be our alternative hypothesis. But it is also important to note our null hypothesis, which is that squirrels are not affected by cloud cover. I watched squirrels every week on Friday for 10 minutes at 9 a.m. at the Kendeda building. And I watched them at 12:30 p.m. behind Tech Tower. Now you may be getting bored so far, so for the next segment, appreciate this montage of squirrels. We recorded the time of day, the weather, and wind and precipitation and topography, and the location of the squirrel in relation to the surrounding things like walkways and roads. And then, after 5 minutes of waiting, we began our 5-minute observation period where we recorded the squirrel's behavior every 20 seconds. But how do you record squirrel behavior, you ask? Well, we recorded them based on if the squirrel was vigilant, foraging, alert feeding, social, or other. We also observed if a squirrel was present or not. We then used our studio to graph squirrel presence versus cloud cover based on a random sample of 100 observations taken from the fall 2024 data from all of our co-observers in our course. In our studio, we cleaned up the data, then organized by squirrel presence and cloud cover, and then made graphs using that data. We then ran a statistical test. This was my code, and this was my graph. My graph consists of graphing the mean squirrels present versus the category of cloud cover recorded during the observation session. After the aforementioned code writing and cleaning, I got this graph. In this case, I chose to run a chi-square test of independence. Why, you ask? Because I had two categorical values, cloud cover and number of squirrels observed, and I wanted to study the data distribution's significance. With a p-value of 0.02267, this is below the common significance level of 0.05, suggesting the result is statistically significant. This means there's a significant association between cloud cover and the number of squirrels present. The chi-square value 29.192 indicates the degree of discrepancy between observed and expected values in my contingency table. A higher value generally reflects a stronger association and is associated with a lower p-value. The degrees of freedom, here 16, reflects the structure of my table. This is important for interpreting the p-value within the chi-square distribution. I, on the other hand, graphed squirrel presence versus cloud cover. Here's my code, and here's my graph. I ran a chi-square test of independence and got the following results. With a p-value of 0.4531, which is a lot higher than the common significance level of 0.05, so the result is statistically not significant. This means that the presence of squirrels is independent of cloud cover in my sample. The chi-squared value, 3.67, shows the degree of discrepancy between the observed and expected values in my table. A lower value reflects a smaller difference between the expected results if the variables are independent versus the actual number of observations. This makes sense, as the p-value shows that these variables are in fact independent. Degrees of freedom, which is 4, is related to the number of categories in my data. This lower value means my distribution is not as spread out and has a lower critical value, which explains if my test statistic is large enough to reject the null hypothesis. This experiment is quite significant as it shows how similar experiments can show wildly different results based on the specific questions being asked, along with the fact that different samples of the same data may look unique. Ideally, these results could assist in understanding when best to observe squirrels depending on cloudiness. However, looking back at our graphs, there is no clear pattern to cloudiness and the number of squirrels. It should also be noted that based on statistical tests, one graph proved invalid and insignificant. Improvements could be made to this project if it is run again. Specifically for our hypothesis, observations could be much more controlled to focus on a specific variable from the start. There were many variables not useful for the experiment, such as wind speed and topography. This experiment is related to ecology as a whole, as we are studying how abiotic factors affect squirrel behavior. This could be taken further to understand squirrel dispersal and habitat choices. It also ties to urban ecology and helps us understand how wildlife interacts with city environments, linking to bigger issues like sustainability and climate action. Prior ecology works like Benson's explore how squirrels adapt to urban environments, while Bonnington et al. Emphasizes the role of features like canopy cover and food availability in shaping squirrel presence. Our findings contribute to understanding environmental influences on wildlife behavior, showing the potential of studies like this to inform biodiversity management in urban areas. While our results were inconclusive, they reinforce the importance of green spaces in supporting both wildlife and human-wildlife interactions. Oh, that was a lot. Are you still with me? Okay, I'm ready. Let's go. Our first relevant sustainable development goal is sustainable cities and communities. Squirrels are an important part of the ecology of a city, and having clean, unpolluted cities is key to conserving their populations. Within the context of the project, we can track differences in squirrel behavior across various parts of the city depending on how green the infrastructure is in each area. Our second SDG is climate action. Super important ecology-wise. With increasing global warming, our project can determine if squirrel behavior changes with more extreme temperatures and climate patterns.
Our third goal is life on land. Well, squirrels are literally life on land.
Yeah, but also the project allows us to study the behavior of this terrestrial life form and understand the logic and reasons why.
Bill Nye the Science Guy.